مساء الخير.
Good afternoon. So welcome back to the second panel of the 20th Annual Energy Conference. In our second panel, we have a slight change to the program. And because of the flights and we will introduce the first speaker, Professor Andrew Alpin, who will be joining us through video conference. I will be speaking in English. You can, for those who don't understand it, you can listen through your headset. Translation is available. Welcome again to the second panel.
I would like to apologize for the presence of Professor Andrew Alpin, which he couldn't make it today due to some reasons concerning the flight, but we will be in touch with him through a video conference. Welcome back again, and we will stick to our program accordingly, and we will start with Professor Andrew Alpin.
Thank you. Okay, I'm going to start now. Ladies and gentlemen, thank you very much, and I hope that the technology is working, and that you can perhaps see me and hear me. I don't think I can hear you. I'm very sorry not to be with you today. It was a problem with the European Airlines last night, so I'm speaking to you from my own home in Newcastle in England. So it's my job today to say a little bit about the potential role of unconventional oil and gas now and into the future. And I will start with the backdrop, of course, of the global energy use. Here is a graph of the way that the population of the Earth has grown in the last 40 or 50 years, and the amount of energy that we are using. And here then is the relationship between the number of people on the planet and the amount of energy that we are using. And the yellow line here is the one-to-one line. So that's the amount of energy which would be used per person if each person was using the same amount of energy as they were in 1965. So we have a double problem here. We have a much increased world population, firstly, and secondly, each new person is using more energy. And 80%, of course, of that energy comes from fossil fuels. And the projections are similar into the future. So that is the backdrop to the issues that we face today. To come specifically then to the unconventional oil and gas, and I really want to say a few words about the current uncertainties, if you like, both in understanding how much unconventional oil and gas there might be underground, and then the more pressing and more difficult problem of what proportion of that resource may be produced now and into the future. We can think about it then in this sort of classic exploration pyramid, going from bottom to top as our information quality improves. And so at the start of exploration, and this is the case in most of the world today outside of North America, then it's the geological analysis that we are undertaking currently, particularly with the geological surveys around the Earth, to try to estimate simply how much unconventional oil and gas there may be in a certain volume of rock. Only when we start drilling do we have an idea about what might be recoverable. And the truth is today, outside of North America, that so few wells have been drilled that really the technically recoverable resource is very poorly constrained. Beyond that, of course, we have to ask the question about what might be economically recoverable. And of course, that's a more complex question, depending not only about how much gas there is in place, but also the extent to which it can be produced at a given price and at a given cost. And then finally, once the plays are much more mature, a substantial number of wells have been drilled, there is a significant production data, only then might we understand what our expected ultimate recovery might be. And it's only now probably in one or two places in North America, for example, Barnett, where these numbers are known with any accuracy at all. So they're the problems we actually face. There's substantial uncertainty currently about simply how much unconventional oil and gas there is in the world. Let me give you one example from here in the UK. This is work done by the British Geological Survey. Remember in the UK that there's only been 2 or 3 shale gas wells drilled in the last few years, but historically there's been substantial drilling for conventional oil. So I would say that the UK is characterised as a country where there is, a moderate database. There is no production data, but there are data from old wells in terms of, for example, the background geology, the organic content of these rocks. What you're seeing here then are the estimates made by the British Geological Survey 1 or 2 years ago as the amount of gas in northern England. They've undertaken a sort of a Monte Carlo simulation, and their best estimate for the gas in place, this is the total gas in place, is around 260 trillion cubic feet. But the ranges then from the sort of the P90 to P10 range from 160 to 450. So that is a factor of 3 of the gas which might be there, even based on sort of a moderate database. The background to this geologically is that to calculate these numbers, we need to have an idea about what the volume of the gas mature shale is, its porosity, what fraction of that porosity may be gas-filled, the organic matter content of the rocks, the amount of adsorbed gas, and the pressures. None of those are known with any certainty. And this is why we have such a wide range of potential gas in place here in northern England. In terms of interaction with the media, these are the numbers which are reported typically in the media, and this is where the excitement comes from, because 260 trillion cubic feet would be equivalent to about 80 years of UK consumption, and that makes the government interested and excited, and it also excites the general public. Of course, the much more interesting and useful question is what fraction of that might be produced. So in other words, the difficulty of moving from resource to reserve. So when we see maps like this, and this is from the EIA, the US EIA, in terms of technically recoverable gas shale resources, then we must understand that there is significant uncertainty in these numbers. The headline numbers then, in terms of the gas shale potential recoverable resource, so a number published in 2011, 190 trillion cubic meters across the world. And what makes that interesting, of course, is that is, in fact, rather similar to the potential total conventional gas. This is from BP data. But we must remember then that these numbers for the unconventionals have very substantial uncertainties. And just as one little example here, in Europe, here is Poland, which was a great hope for Europe just a few years ago. We know today that several companies have actually pulled out of Poland. So, if you want, the economics of that area are very uncertain. So, although these numbers are sort of exciting from a hydrocarbon point of view, we do need to understand that there is significant uncertainty in the numbers. And part of the reason for that is that the recoverable resource are based on very, very, very simplistic geological criteria. So these were the criteria for the percentage of the gas which could be recovered from the US EIA. So let me just read that to you. So favourable recovery, 25%. Geologically, that would mean low clay content, low to moderate geological complexity, favourable reservoir properties such as an overpressured shale formation and high gas-filled porosity. These are extremely general geological criteria, and it just simply indicates the lack of certainty that we have in terms of what fraction of the gas in place might be recovered as a function of a given set of geological circumstances. When we come down to the bottom of the slide here, with oil, then the numbers which are sort of coming out of the US today from the Eagleford and the Bakken formations, for example, are probably 5% at best. And that would be for a very light oil. If we look at the more typical black oils, then that number probably is below 5%. So the recovery factors then are probably poorly known, and especially for oil, are very low. And that is why then, when we look at the recoverable resources that have been published over the last 20 or 30 years, or even focusing just on the last 5 or 6 years, we have a range of figures here for the global recoverable resources, which range from on the order of 20 or 30 trillion cubic meters up to numbers like 200. So these are substantial uncertainties currently. And I think it's true to say that outside the US that these numbers are very poorly known. Certainly speaking from a European perspective, I think we feel very uncertain about the European resources, and the European Union currently is putting some funds into trying to investigate these numbers in more detail. Let us move then, second part of my talk, to the production data, which of course comes entirely from the US. And I know the next speaker is going to be saying more about the situation in the US, so I'll keep this relatively short. In terms of oil, then we'll see here on the top right-hand side of this slide, and I hope the slides are sort of keeping it with my voice. I can't control that, I'm afraid. So hopefully you can see what I can see on the screen. But here in the top right, then we have the weekly US crude oil production from January 1989 to August 2013. This steady decline through 2005, 2006, 2007. And then the upturn just in the last few years, driven primarily from production from Southwest Texas, the Eagleford formation, and in North Dakota in the Bakken formation. Here is I was very lucky a few years ago to be able to go and see the geological outcrops of the Eagleford right down here in the wild of Southwest Texas. And here is this astonishing picture of the way that oil production has increased in that part of the world from 2010 or 2008, where it was basically zero, to something like 400,000 barrels per day in 2012. And that, of course, has driven this remarkable increase in US oil production just in the last few years. And I think the next speaker will probably say a little bit more about that. In terms of gas, where there are more data, one of the slightly disconcerting realities of shale gas is that the decline curves are very, very steep. There are two parts to this slide. On the left-hand side, we've just picked out a small number of wells from different US plays, so the Haynesville, the Marcellus, the Barnett, the Fayetteville, and the Woodford. And this then is the gas production per day through time, and this is in months. So we'll see then that the average 3-year decline for these wells is something like 80 or 85%. And that, of course, means that in order to maintain production, a very substantial number of wells need to be drilled per unit time. So this is a kind of a fundamental issue with shales, the nature of the shales, in particular the permeability, their ductility, and the way that the production shuts off so quickly. So that is disconcerting. Interestingly, in the Barnett, which is, I suppose, the grandfather of the US gas plays, there's been a very nice piece of work published from the University of Texas by Pat Seck et al., where they have now studied 8,000 Barnett wells. The data here are slightly different to the ones on the left, but the concept is the same, where we're looking at gas recovery as a function of time. And here are all these data. You can see that there's a lot of noise and therefore uncertainty, not uncertainty in the data, but a lot of variability in the data. But a lot of the data is falling at this sort of exponential decline, which are very similar to the ones that we see on the left, but now based on something like 8,000 wells. Now that then enables us to consider how this production may change through time. So we can start to make some predictions about how these gas plays may play out in the future. This is from the same piece of work where we're looking at production. This is in trillion standard cubic feet against the year. And there is a lower bound and upper bound which relates to the uncertainty in the production data from those 8,000 wells. Optimistically, if no more wells are drilled, the total production from the Barnett may be as high as 25 trillion cubic feet. Pessimistically, looking at the other end of the data, if no more wells were drilled, then production from the Barnett will be finishing within just a few years around 2020. So there is significant uncertainty in these numbers, and you can see that the economics will depend very much about whether the lower or the upper bound is the more appropriate extrapolation from the data. So this is telling us that even with substantial production data, there is still considerable uncertainty about extrapolating into the future. The average estimated ultimate recovery from these 8,000 wells is somewhere between 1 and 3 billion cubic feet per well. And again, in terms of the economics, then of course the production per well has a huge impact on the economics. So really, just reinforcing them, the uncertainties looking into the future. It's interesting to compare those data with the monthly US dry shale gas production, which we are seeing here from the beginning of 2000 to approximately the present day. This is the Barnett, this brown colour here, and you can see from around 2009 the production from the Barnett has approximately flatlined. It has declined in the Haynesville and is flatlining in, for example, the Fayetteville and the Woodford here. Now, some of this might reflect the move from gas to oil in the US because of the much greater financial value of oil currently compared to gas, or it may also indicate that as one moves away from the so-called sweet spots, the best place of production, then inevitably the production rate per well will decline. So it's a very interesting thing to sort of to think about how the future of this industry looks like in the US right now, and what we can learn from these data on from the global perspective. Okay, let's move into the future in the last few minutes of my presentation. This is from the most recent BP survey of energy consumption, looking now to forward to 2035, and just reminding us that that fossil fuels will continue to be an incredibly important mix, part of our energy mix, and the proportion of oil, gas, and coal probably won't change too much over the next 20 or 30 years. So there's no doubt that fossil fuels, in one form or another, will be an incredibly important energy source for the future. And of course, our energy consumption, our energy demands are increasing by several percent year on year. I'm going to just pick out a couple of examples to think about what the issues are outside the US. So I'm going to say a few words about Europe and a few words about China. And the issues in those two areas are very, very different. In Europe, there is a significant issue with energy security. So currently in Europe, and this is quite similar in most individual European countries, that something like 60 or 80% of our fossil fuels, our gas and our oil, are imported. So Europe is hugely dependent on imports from around the planet. The second point then is that there's a very strong drive in Europe currently to reduce greenhouse gas emissions. So the European Union has suggested that it will reduce its CO2 emissions by 2030, 80% by 2050. And so on the one hand, we have a great need for fossil fuels. On the other hand, there is a big drive to reduce the emissions of greenhouse gases. Superimposed on those drivers, of course, Europe has a much higher population density than many parts of the United States where shale gas is being produced. And currently, people are simply not in favour of significant production. In Europe, we want oil and gas, but we prefer, in many cases, that it comes from outside our borders. So it's a very interesting sort of combination here about societal acceptance married with politics. These are scenes from one of the few wells that have been drilled in the onshore UK. This is the single green MP, a member of Parliament, who's been arrested for protesting at one of the sites in southern England, and here are the police allowing some workers to come into one of the sites. So for each site that is drilled in Europe, there are significant protests. So that is one of the issues that we need to engage the public if we're going to make this work in Europe. And the other factor as well is that the geology in Europe is more complicated than it is in the US. And there's an example of that. Here we are in the UK. Northern England is the main potential area for shale gas. And we don't need to worry too much about the geology in here. But in order to make to produce significant amounts of shale gas in the UK, we are going to need to drill something like 25,000 wells or maybe 2,500 pads to recover about 40 trillion cubic feet from Northern England. Now that is about 13 years of UK consumption, which is a useful prize. But the number of wells are huge compared to what we have done in the last 50 years. We've drilled about 20 onshore wells per year in the last century. We're going to need to upscale that substantially in order to make any commercial gas production. And Northern England has a population of something like 8 million. So those are the sort of the issues which Europe is facing if this industry is going to take off in the next sort of 5 to 10 years. Moving across the planet to China, very, very different set of circumstances, but again, very challenging. Of course, the Chinese 21st century industrial revolution has been driven essentially by coal. And we can see here that China now is burning about the same amount of coal as the rest of the world put together. There are concerns in China now about air pollution in cities, and it was just last week when President Xi suggested that China's CO2 emissions would peak by 2030 and would decline after that. So again, there's a drivers there in terms of air quality and in terms of greenhouse gases. China does have significant unconventional resources, there is no doubt about that. But the issues there are that first, that many of them are in very remote parts of China, which is a problem in terms of taking infrastructure in, and those areas are often very dry. So in terms of the amount of water that's needed to drill wells, that would be an issue. In other parts where there is significant shale gas in China, the population densities are quite high, as in Europe. So China has a different set of issues to Europe, but combined together, the one that we all share are the issues to do with sort of climate change and greenhouse gases. Can we do better? Should we do better? Must we do better? Especially as a geoscientist, I would argue absolutely yes. In the top right here, we have the average estimated ultimate recovery per well from a large number of US wells. Hello? I'm sorry, the phone just went there. And I'm just going to finish in just a couple of minutes. So we should do better. The average recovery per well is hugely variable, and in the US, then 30% of the wells in the fracs actually fail. So that's just an annual waste of something like $100 billion. So we need to do better. We need to do better in water management, in water stressed areas, for example. That would have to be the case in China. In Europe especially, we need a social license to operate. We need to engage the public if this industry is going to take off in the UK. And it's going to be essentially to have both effective regulation and monitoring to ensure that the public are confident that this industry onshore can develop. In places like Europe, we have the downside of high population density. The upside of that is we have a lot of infrastructure, and so we need to use that infrastructure in a more clever way into the future. So my concluding comments then. Point one, I've not mentioned tight gas, heavy oil, or underground coal gasification. There are other forms of unconventional energy which may be important in the future. In the OECD countries, most of the hydrocarbon growth will be made in unconventionals, and the majority of that will be in North America. In contrast, in the non-OECD countries, in the next 10 or 20 years, probably most of the hydrocarbon growth will still be conventional rather than unconventional, even though there are substantial unconventional resources. Following the US shale success will be harder elsewhere for a variety of reasons, and those reasons and those issues will vary from country to country. We must do it better. We need to engage the public. We need to manage the water supply more effectively, and we need better geoscience and engineering to improve the recovery per well. And from a climate perspective, swapping coal for gas helps us short term in the next 20 or 30 years, but it does not significantly affect our climate predictions longer term. So we must see unconventional gas as a transition fuel to renewables and to smarter cities. And that's all from me. Thank you for listening to me from my home in Newcastle, UK, where it's grey, cold and cloudy. So please enjoy the sun in Abu Dhabi. So thank you very much.
On your behalf, we would like to thank Professor Andrew Alpin for such a significant presentation on the assessing the role of unconventional oil and gas. Professor Alpin, as you know, is the professor of unconventional petroleum from Durham University, USA. Thank you very much, Professor William. For the sake of timing, and we will not have chance to take questions and answers for Professor Alpin, and we will continue with our program as usual. Now, from the floor, my respective audience, I would like to introduce Dr. Michel Foss, he's the chief energy economist, the Bureau of Economic Geology, and from the University of Texas at Austin, USA. Professor Michel has more than 35 years of experience in the field of energy. She advises US and international energy companies, publishes and speaks widely, and provides public commentary and testimony. Her experience or expertise includes global oil and gas, LNG, gas power and energy scenarios and outlooks. There is much to say about Dr. Foss. As a limited time, you can go through the documents that it is in your hand. Please feel free, and you'll find more about her CV and her experience and achievements in the field of oil and gas. I would like to introduce Dr. Michel Foss in her presentation entitled "The U.S. Unconventional Oil and Gas Boom and the Potential for Energy Independence." Dr. Michel, the floor is yours.
Thank you. Interesting that we managed to get it done from Andrew's remote location. By the way, I will thank Andrew for presenting the U.S. story nicely, and in particular, a lot of University of Texas research, which several of his slides included the results of a multi-year investigation that we have going on at the Bureau of Economic Geology on our shale basins. And I'm going to show you some of that data as well, but more advanced. The Bureau of Economic Geology, my parent organization, is the state of Texas Geological Survey, as well as the largest research program at the University of Texas. So on our team, we have geoscientists, as well as economists and engineers, all working collaboratively to look at our oil and gas resources in the United States, Texas and in the United States. As you can imagine, there's a great deal of interest in what we've accomplished in the United States when it comes to oil and gas production and growth in that production. And a lot of it does come from our shale basins. What this has done really is breathe new life into the domestic industry in a number of ways. And what I really wanted to do was give you a sense of the business and economic conditions that have fostered that development. Traditionally in the United States, the onshore oil and gas businesses had been in a state of decline. Our fields are very mature. We had produced from them very heavily, especially during World War II, to provide that wartime effort. Most of the Texas oil fields, in fact, were brought into production in that time frame and in a very accelerated way. So we actually had damaged oil fields, we had damaged reservoirs, we had worked our oil and gas asset base very, very, very hard. And by the time the 1970s approached, we were in a substantial state of decline and maturity in our oil and gas resource space in the United States. And so having opportunities to develop resources from the shale basins for domestic producers in particular has been a great boon to the industry. It's very expensive, it's very challenging, but it's very alluring. And the reason is that the shale plays constitute the source rocks that underlie conventional oil and gas fields. So for anyone who is wondering about the distribution of shale resources around the world, the first thing to do is to look at a global map of oil and gas production, and that will tell you all of the locations around the world where you might find resource rocks, shale plays that could be conducive to development. I think that you may have noticed on the map that was shown earlier from the U.S. Energy Information Administration, the distribution of shale basins worldwide, that there was nothing showing for this region. Did anyone happen to notice that? It's pretty obvious when you look at a map of global resources and you see nothing for this particular part of the world. I've asked my dear friends and colleagues in the Department of Energy about this. Why did they exclude what is probably the most prolific shale resource region? And the answer was, well, we're trying to show what the rest of the world could look like, not just the Middle East and not the Persian Gulf or Arabian Gulf region. Of course, the reality is that with some time and with some investigation, I think you'll discover that you have very large shale resource endowments here, and the question will be when and how you want to try to develop those, what will be the timing, what will be the commitment, and so on. To just bring the story forward, really, there was no way to commercialize our plays without the strong commodity price signals that we've had. First, for natural gas, our Henry Hub price index in the United States has been very strong in the 2000s until recent years. When people believe that the price of methane will rise to $12 after being at $8, or maybe even $15 per million BTU, that is a very strong incentive to drill. And so the large basins like the Barnett that Andrew talked about previously were successfully developed during that time frame. Likewise, it's very easy to mobilize capital for investment when you have an oil price signal that is well above $100 per barrel. And so that provided a great incentive to test the shale oil plays in North Dakota, the Bakken, in West Texas, and the Eagle Ford that was already discussed. However, this is very demanding, it's very complicated, it's very challenging for a number of reasons, and not just because the geology is complex, which it is, but also because we're pursuing oil and gas production growth in locations that haven't been well served by infrastructure, so we've had any number of logistical issues, getting pipelines built, storage facilities, and other things. The timing and the kinds of business conditions as you go across the oil and gas value chain vary. What is good for producers is not necessarily good for companies that develop storage facilities or pipelines, and what is good for them is not necessarily good for people who develop the end-use applications, petrochemicals and refining. We have had very mixed conditions on the demand side because of recession and warm winters and other things. And we have a constant debate about trade and exports, and I was going to just leave you a message on that as I close. Of course, in the short term, where we are is a great deal of worry about the low side of oil prices. That is obviously counteracted by all of the things that tend to impact oil supply on the geopolitical side to keep price high. Longer term, I think the bottom line message for all of you to think about is this. When it comes to this specific question, what is going on in the United States with respect to energy security, and how are our shale plays, our unconventional plays, affecting that? Our conversations are really about natural gas. We have had this blessing of oil production growth. This is a temporal thing. It's not going to last forever. The lifespan is actually going to be rather short. But it's still very exciting to have real growth in oil production in a country where we never thought we would have growth in oil production again. But we are a natural gas-rich province. That is our main resource. It's huge. It's abundant. When you put the United States and Canada together, it's world-class. The question is how to develop it, how to commercialize it. Can we develop the end uses around natural gas that would compete with petroleum fuels? So can we push natural gas into transportation and other applications so that you would begin to see some trade-offs with crude oil as the dominant energy source? That's really the big energy security debate for the United States. So let me just show you really quickly a few of the highlights in this slide deck, and these, of course, will be left with the center for use beyond the conference today. I will tell you that we've had a low oil price outlook in my group since 2011. This is a result of a great deal of work that I did for Oxford University, for the Oxford Institute for Energy Studies a few years ago to develop scenarios on natural gas, but one can't look at natural gas without looking at oil, and one can't look at oil without realizing that the world is rich in crude oil sources, and we do a very good job of developing them when we have the right kinds of business conditions. And so the thin green line is our outlook. We've been expecting a lower oil price for some time, so we're finally there. We are expecting it to possibly remain low and flat for some years, and this is because of global economic conditions as well as the supply picture. I'll tell you that, generally speaking, in the Bureau of Economic Geology, we are not peakologists. For those of you who like to think about whether we have reached peak oil worldwide, we have clearly not. There is a great deal of premium oil yet to produce, and I don't mean just in North America, but certainly out here as well. Likewise, what this means, a corollary for natural gas is a higher natural gas price. So this is the bottom line story for the US, and this will be true worldwide as people pursue unconventional plays. It is a liquids business. Gas is a byproduct. The less that we invest in crude oil, then the more we need to invest in methane delivery. So the thin red line reflects what we think could happen with methane prices in a world in which oil prices remain low and flat for some period of time. Companies will need to invest in non-associated gas, dry gas, to be able to meet all of the demand for natural gas that we are in the process of creating right now. Finally, one of the more important things for us, and really one of the more important things for investors anywhere, is the difference across all of the different kinds of molecules that get sold. And the primary relationship is between oil on a per barrel basis and natural gas on an MCF basis or million BTU basis. It's very easy to think about high-cost commercialization strategies like gas to liquids when you have a very high oil price and a very low natural gas price. And this is nirvana, really, when it comes to natural gas development. Taking natural gas feedstock, running it through a Fischer-Tropsch process, getting a middle distillate out of that that can go straight into a refinery and straight into the transportation sector. Qatar has made an enormous gamble on that and is working very hard to try to test gas to liquids as a strategy for their natural gas resource. A lot of other places, a lot of other countries, including in the United States, we would like to try to do the same thing. But a lower oil price, a higher natural gas price, obviously doesn't facilitate that very well. So the thin blue line in this picture is where we expect the oil-gas price spread to settle out, assuming that the world looks the way that we think it could look in the scenarios that we've built. So this just gives you an idea of what some of the thinking is in the United States about what might happen in terms of the key commodity prices that drive our business. So just to quickly move through some of these concepts, the good news, of course, lots of growth in oil production in the United States. It's caused us to move up in the ranking of countries when it comes to reserves and production growth. The same thing is true on the natural gas side. Even in a more pronounced way, we are the largest natural gas producer, and that is likely to stay that way for a while unless we see business conditions really being impacted heavily by oil prices. Just to talk about how hard this is, though, for a minute. So on the left, we have crude oil production growth in the United States. On the right, we have dry gas yields, so the amount of methane that comes into the market from oil and gas production in the United States. Rough, back-of-the-envelope estimate. We've been growing oil production in the United States in excess of 20%, 20 to 30%. That is an enormous effort for our industry to make. We think that oil production growth rates in the U.S. have to remain 15 to 18% year on year in order to achieve gas production rates of 4 to 6%. That should give you some idea of the sensitivity of our businesses to commodity prices and what could happen going forward. One of the dilemmas in all of this has been the emphasis on shale for investment to the exclusion of everything else. If you have an idea for a conventional oil or a conventional natural gas prospect in the United States and you're looking for financial backers, good luck. No one is interested in that. But if you go to New York and you show the shale story, everybody is willing to jump in. So this has been a Wall Street-dominated business. An enormous amount of speculative investment coming into the shale plays, a huge amount of leverage for the producer community because most of them have borrowed very, very heavily to sustain the enormous capital investment programs that are required for these shale plays, given the decline curves and other issues that the producers face. So this has caused shale to have an overweighted percentage of our overall
2 minutes
portfolio.
to go, sorry. 2 minutes to go, Dr. Michelle.
I'm sorry? Sure. I don't get extra time because of the technical difficulties. So the point remains is that shale is dominant, and it's dominant mostly by accident because of the difficulty of convincing backers to invest in traditional, conventional oil and gas projects. Now let me just show you some of the work at the Bureau a little more closely so that you'll understand this. This first slide here, this is not from the Bureau of Economic Geology. This was a proprietary ISAPAC that was done in about the 2008-2009 timeframe. This is the Barnett Field, the enormous field that it basically surrounds the Dallas-Fort Worth area in Texas. If you look at the darkest purple locations on this map, those are the best locations for drilling and for success. So if you look at the sweet spot in this table, those dark locations, dark purple locations, Those wells in that time frame yielded about 3 BCF total for the life of the well. Everything else outside of that is less attractive. Everything else. Now, here is the Bureau's map. We produced this in 2012 as part of the Shale Resource Assessment Program that we've been in. The darkest red locations correspond to the darkest purple locations in the previous map. And you will see that it's about the same. So what we've learned between 2008 roughly and 2012 is that the geology doesn't change. We've been able to improve production techniques a little bit. We've improved technical recovery a little bit. By the time the Bureau produced this, total BCF per well on average for the best locations in the Barnett was about 4 BCF per well as opposed to the 3 BCF in the 2008-2009 timeframe. But again, everything out of the darkest red locations is less attractive for drilling. This is the kind of thing that you see in decline curves. The best wells are represented by the dark blue line at the top. You get higher initial production rates, but a very fast drop-off in decline. It's worse for oil than it is for gas. Oil molecules are larger, so the decline rates are faster. The wells exhaust themselves more quickly and have to be replaced. This includes now a variety of different shale basins, including the giant Marcellus Basin in the northeast part of the country. And you can see that it doesn't matter where you are. You get slightly better initial production rates. Haynesville and Marcellus are the two top locations. So you can see that the best wells in those locations will give you in the neighborhood of 5 to 6 TCF, but everything else falls off very rapidly, and the decline curves are even steeper as you go forward. And then finally, to give you a sense of the economics on all of this, these are computed break-even averages based on all of the information that we have available to us to look at what it costs for producers to participate in these plays. And we raise the question of whether or not these plays are competitive at a $4 natural gas price, so $4 per million BTU at our main price index in the United States of Henry Hub. The same story will play out for oil when we eventually produce those charts. So the first place to look is the Barnett again, where we have 16,000 wells drilled. We know much better what the cost structure of those wells are. Some Barnett wells have been economic. The very, very best acreage has been economic below $4, but very, very soon after that, everything increases in cost. So when you look at this, Tier 1 are the very best wells in the very best locations. Tier 10 is the very worst wells in the very worst locations. You could see the effect of what happens when you have liquids that you can produce and commercialize. This makes drilling very attractive, much more attractive, and this pushes natural gas into the byproduct territory. Fayetteville, for comparison, Fayetteville shallow, which is cheaper to drill, Fayetteville medium, and then Fayetteville deep, which is more expensive. The Haynesville wells are some of the most expensive. This is North Louisiana and a bit in East Texas. Pennsylvania Marcellus, dry gas, methane only. Very difficult to do that and be competitive in low gas prices. As you add molecules and make the gas stream richer, it's a little bit better. This is the current problem for the industry, that dotted line at the bottom. If you are a producer in the Marcellus and you have no transportation option and you're producing ethane and a lot of methane, you're basically taking a negative price. And everyone has been trying to fix that since being there. So, in summary, it's a liquids business. The costs are very high. Commodity prices make these businesses very complex. Depending on what you're producing, it's very difficult to actually get a weighted average price that is even the US domestic price for oil. Most of the producers in the United States in these plays have not been getting a full crude oil price per barrel. They've been getting substantially less than that because condensates are cheaper, natural gas liquids are cheaper, and methane is definitely cheaper. And then let me just show you one quick thing before we move on. I'm going to flash through all of this because I just want to give you a sense of where we're headed in terms of demand. So I'm going to build this demand stack. This is for natural gas. Demand for oil, as best everyone can see, is flat going forward. Whether or not you believe that, well, we'll have to see. But demand for natural gas is what's very interesting. The residential commercial segment, this pink layer, this is pretty constant. It doesn't change very much. It's mainly winter heating load, and so it can vary depending on seasonal patterns. Industrial demand is growing. Our estimate of industrial gas demand going forward is actually higher than the U.S. government estimate, and we don't include everything that they include in their outlook. So we're having lots of conversations with them right now because our growth rates are much, much stronger than U.S., and it's dominated by petrochemicals. This is what could happen in electric power. Our estimate of what could be used for electric power generation in the United States by 2030 is almost 16 trillion cubic feet. This compares to the U.S. government estimate of 10. When you add renewables to the power mix, you need to back it up with something, and we back it up with natural gas. That puts a lot of demand on the gas deliverability to be able to meet all of those load requirements. In addition, we have a great deal happening on the environmental front on emissions control in the United States that is affecting how people plan power projects. We already have a lot of gas turbine capacity baked in to forecasts because that's the only thing that anyone can build. Pipeline exports, for everyone who is looking for exports out of the United States, we're going to export to ourselves first. We're exporting gas to Canada, and we're exporting gas to Mexico. Now, that may sound strange. U.S. gas currently accounts for about 30% of Canadian natural gas use, and we account for about 30% of Mexican natural gas use. I think that we will probably do that more than we export. The best that we can come up with in LNG exports from the United States is only about 1 trillion cubic feet. Part of that reflects the scenarios that we've built on commodity prices, but also it reflects the competitiveness in the LNG industry worldwide and the fact that with everyone competing for gas in the United States for our own demand as well as for exports north and south, it's going to be hard to fill up those LNG tankers. So that puts us to a possible 40 trillion cubic feet of natural gas demand by 2030. This is higher than most other forecasts. For those of you who use IHS, Cambridge Energy, they are the closest to us of other forecasters in terms of demand. The black line is the U.S. government expectation for natural gas supply going forward. And so therefore, what you see is a potential imbalance in the market that we have to be thinking about. This is a different story than I think.
I'll give you more time.
Well, I'm wrapping up.
It is a very interesting issue, and I know that is a long thing, but we can give Dr. Foss 3 minutes more to wrap up the important conclusion on your presentation, please.
Right. So, in conclusion, we have a rich resource base, but it's expensive and it's challenging. It looks cheap because we have a lot of supply, not many market outlets. We have low price signals as a result. But I think that everybody really needs to understand that it's very difficult to sustain our shale plays in an oil price environment in which oil is $80 or below. It's definitely tough to sustain the shale gas plays with a Henry Hub price of $4 or below. I think some of the best evidence that you can see for what kinds of impacts are taking place in the United States right now are the Halliburton-Baker Hughes proposed merger. That's a signal of the stress in the marketplace, the combination of lower oil price, high cost of business, and some reality checks on expectations going forward. As we look across the industry, we're seeing reductions in drilling commitments, reductions in capital expenditures. Companies are reducing the number of rigs that they plan to deploy. And so these effects will build over time over the next few months, and we'll see where we stand after that. But by contrast, we have a very robust demand story. When resources are cheap, customers try to use them. So this is one of those classic moments in time when we look at the next commodity price signal being developed, because when you have rapid growth in demand and you have something that will impact the supply side, sooner or later, this will show up in commodity prices, and we will expect to see a recovery in oil price as a result of that. So I hope this gives you a little more of a feel for what's been going on in our country, and a little bit of a feel for how it's impacted thinking on energy security. I have recommended to many of our colleagues in Washington that we don't lose our skills in looking at energy geopolitics, because I think that we're going to need those on down the road, to the extent that the United States at some point will need to import oil as opposed to producing our own or relying on Canada. So thank you.
Thank you very much for Dr. Michelle Foss for such an amazing scenario about what's going on there in the States. Really, it's a huge projection, especially the pipeline expulsion of the gas, intercontinental and inter-countries to Canada and others. I'm sure that you have a lot of things to consider. Because of the time, I'm really sorry. We are running out of time. Please be patient with us, and please bear with us these few moments. Now the floor will be given to Professor Mark Deakin. And Professor Deakin is the director of the Center of Sustainable Communities from Edinburgh, UK. So we'll move from USA to UK. Just briefly, Mark Deakin, professor, is a professor of built environment and the head of the Center for Sustainable Communities in the Institute for Sustainable Construction at Edinburgh University. His research is interdisciplinary, cutting across academic, scientific, and technical boundaries. His work has involved him developing ICT-related policies, mapping out the social needs and informational requirements for urban sustainability, and investigating the challenge that e-governance and the dissemination of communication technologies pose for the development of energy efficiency, low carbon zones, and smart city districts. It's an interesting issue for sustainability and for the green approach. Dr. Mark, the floor is yours.
Okay, well, thank you very much. And again, thank you very much for this invitation to speak today. It's most welcome. I was asked to speak on smart cities and something around renewable energies within smart cities, so that this is the presentation I put together to try and meet those particular requirements. I'll move on. As you can see, the emphasis in terms of smart cities will be quite European. Smart cities are not a new phenomenon. I think Singapore was probably the first city to declare itself smart around about 1993. Since then, we've had Songo in South Korea. We've also had Mazda here in the UAE. And we've also had Planet IT Valley in Portugal. But today, I want to really focus on not new cities, which have been built from, in effect, the ground up, but actually the application of smart technologies within existing cities. Because as we all know, in any good year, a boom year, a year where oil prices are rock bottom and the economy is booming or surging ahead, only 1% of the of additional floor space gets added to the standing stock. So there's always a 99% legacy that we have to deal with. And that's really one of the main challenges to apply these particular applications en masse. and to create the sort of step changes which are looked for and hoped to be full of prospect in terms of dealing with climate change and in particular climate warming in that sense, or global warming, sorry, in that sense. Okay, so those are some of the issues which I will touch upon. The base for this is drawn from our research, obviously, in Edinburgh. We had one of the first smart city projects to be funded by the European Commission, and obviously have disseminated quite a bit of work out of that and follow-up projects which we've managed to procure on the back of that particular success. We're working through this notion of there's been an intelligent city, now we're moving to a smart city, we're creating smarter cities, we're governing them, we can now model them because we have the technology and the instruments to do that, and analyse this particular transition so that it isn't a giant leap of faith, it is a natural step and progression in that respect. And we applied some of these ideas in the Gulf last year in looking at the transition of some cities from sustainable to intelligent and then more latterly to smart status. And what I will draw upon today is mainly from this particular text, which is due to be published in January next year, on mass retrofitting as one of the major prospects for delivering energy-efficient, low-carbon zones. Okay. Now, this is the sort of network representation that we built up for the European Commission, and it was funded by the European Investment Bank. We were asked to analyse smart cities in Europe as existing cities, which we could leverage the likes of the ICT applications from Songo, also the energy applications from Mazda, and also the Internet of Things applications from Planet Valley IT in Portugal, but within existing cities, not new, existing settlements of a metropolitan scale in that respect. So we were asked to study Manchester, Amsterdam, Malmo and Barcelona because they also declare themselves smart and want to manage growth under that particular strategy. And the strategy, as we found the common denominators, or the principal components, shall we say, are these represented here as the columns. It's predicated upon a digital infrastructure and obviously data management, and then folding in renewable energy to support smart buildings, and also hopefully transportation too, as the major components of energy consumption, okay, within our built environments and obviously the way we consume them in everyday life, okay. What we found, there was two trends or two emergent thematics that were cross-cutting and therefore interdisciplinary, and obviously held out great potential for integration as a consequence of that. First, there was, well, how can the digital infrastructure, the high-speed broadband, those high-level issues, data collection, storage, etc., underpin what's going on in the renewable energy sector and also the drive towards smart buildings? Because there wasn't a lot of synergy. There was a lot of potential, but we couldn't find evidence of much synergy there. And that was sort of one theme or one direction which we explored. We call that the informatic dimension of smart cities in that respect. And obviously a lot of work has been done over the past 5 years or so, and it seemed to peak around about 2009 to 2011. Okay? And then we had another underlying trend, which was, okay, well, how can the IoT, Internet of Things, actually support renewable energy and smart buildings? So it seems like these two constituencies, or communities, practices, professional bodies, core occupations, whatever, were asking the same questions of each other. And there seemed to be a crossover point, which obviously is identified there, where the black meets the green, and a lot of, obviously, potential to actually explore that relationship, that coupling, shall we say, a little bit more closely. And we called the green theme the energetics of smart city, which obviously is the primary focus of this particular conference today. And that came to the fore 2012, 2014, within these particular applications, i.e. renewable energy, smart buildings, and hopefully leading on to smart transportation as well. Okay. And as a consequence, the first developments were called smart, and the seconds are now being called smart and sustainable. So even in the academic communities, never mind the professional communities, there does seem to be an acceptance of a close coupling between smart applications and the leveraging of sustainable development. That seems to be the ideal marriage, shall we say, to fold in everybody's expectations from the city of the future, i.e. for it to be both smart in technological applications and sustainable in terms of supporting the environment and protecting our cultural heritage and all the rest of it, which expectations come from those particular types of aims and objectives. Okay. So again, we managed to disseminate some of this quite successfully under this concept of a triple helix model to support smart city development, which is government-led, industry-driven, university-supported synergies around this sort of three-way development of smart and sustainable cities. And this is core to the basic growth strategy for the European Commission. This work folded into the 2020 strategy on smart growth, sustainable growth, and also inclusive growth, which is the basic agenda for Horizon 2020, which you may know is Europe's core research and technological investment program over the next 10 years or so. Okay. And again, much more funding has been provided to support and leverage these types of applications. Okay. So historically, a lot of the applications went on smart buildings. Then we wanted to widen that out or broaden the agenda, the metrics of it, and obviously therefore create a new sort of boundary space identified here, and see whether that could become a conduit for leveraging these types of innovations and these synergies in smart and sustainable. And also log that in some sort of concept, which is this idea of a city district manifold for the undergridding, as in the title, of energy efficient low carbon zones, which can work on multiple scales, depending upon what type of application we're actually working with, who's promoting it, how much investment's involved, et cetera, et cetera. So there just seems to be a universal capacity there for an infinite number of applications. Okay. So that's a sort of conceptual framework, modeling, etc. But where are these city districts which demonstrate the potential and the actual performances of this particular manifold? Okay, so we obviously worked on and identified some of these, as you can identify here, mainly in Northern Europe, which go under the name of Vauban and Reisenfeld, which is very successful and popular, Hanneby in Stockholm, Kreuzberg, again in Germany, as in Vauban, the Royal Seaport, again in Stockholm, and Hackbridge, which is in London, one quite close to my heart, in terms of the additional research that we've carried out. Okay, so what's the headline news there? Well, the headline news is, yes, urban morphology does matter. There was a paper in 2005 from MIT, which was used earlier as a reference point, by the head of Sense Lab there, Carlo Ratti, who said, we can reduce carbon emissions by 50% if we get the urban morphology right. If we just redesign the city, we can save at least 50% equivalent energy and also carbon emissions, and therefore make a great dent in the global warming which is going on, and obviously make a significant contribution to humanity. Do these particular savings for these city districts sort of bear that out? Well, you can see in terms of the targets for the European Union, which have been set so far, 2020, 20%, 2030, 40%, 2040, 60%, and 2050, 80%, I think was referenced this morning. That must be the most recent targets. Then most of them meet the 2030 targets, and therefore are way ahead, and therefore are advanced. Some of them perform even higher, particularly in terms of carbon reduction there. You can see from the Royal Seaport. And these are not all the same types of districts either. This is one of the great things about urban morphology, is its diversity. You've got classification there of Vauban and Reisenfeld as an urban extension, Hammarby as an urban extension, Kronsberg as an urban infill, Royal Seaport as an urban infill, and Hackbridge as a urban retrofit in that aspect. So the diversity in the composition, but all, providing the prospect of major energy and savings and carbon reductions. How did they do that? Well, let's look at the one that's championing the highest savings in that sense, or reductions. That's obviously the Royal Seaport, which is an experiment which is started. It will be rolled out fully over the next 10 to 15 years to completion. And there it's argued that there is a smart dividend for sustainable city districts, in neighbourhood communities with emerging post-carbon economies in that respect. So sort of syntax which is emerging around the prospect, and how to realise that is obviously symbolised there on my right-hand side here, in terms of the Smart Grid Lab, the decentralised combined heat and power, distributed energy system, and also obviously solar, wind, battery-powered, waste recycling, zero, energy economy concept, which is symbolised in that particular illustration there. Well, they are projecting, obviously, to reduce carbon emissions by 90%, okay, which sounds astounding in that regard. And if that's true, then, hey, let's get on that particular bandwagon and follow that particular trend, because it seems as though it would solve the major problem which faces, one of the major problems anyway that faces the globe at this present time. Okay, but that can also be seen with this urban retrofit as well, in the sense that projected savings are 80% and in energy 70%. So again, these particular types of morphologies, urban infill and urban retrofit, do seem to provide a lot of potential, and therefore would make very, very good demonstrators of what can be achieved if once engineered and embedded and in situ and operational and usage. Obviously those post-evaluation studies do confirm that this particular level of saving and reduction has been manifest in that sense. So what I'd like to do just for a couple of minutes is just focus briefly on a leading smart and sustainable city district, which is Hackbridge in that sense, and just look at this particular case study to see what sort of application this represents and what the expectations are in terms of, say, a protocol to follow if you want to develop one of these city district applications. Okay. Key thing about this is it actually covers all the dimensions or components of smart and sustainable, rather than just focusing on smart buildings or renewable energy. It also knows that data management and digital infrastructure has to be folded in if it is going to work as a integrated entity able to deliver those particular savings and give those reductions as well. So the parameters become a lot wider. Why is Hackbridge significant? Well, it is the home of One Planet Living, which is the other model to the International Panel on Climate Change, which is saying, keep within the 2% level of global warming, which currently exists. They use a different set of metrics, which is this One Planet Living. As you can see there, there's 10 principles, zero carbon, zero waste, sustainable transport, etc., etc., etc. But it translates into an ecological footprint model, which was the battleground in the middle of the last decade as to which model would be used as the global comparator for measuring global change. Obviously, the ecological footprint goes back to the physiocrats and Malthus and Ricardo and all the rest, and bioproductivity, and is linked very much to the earth and therefore to the land as a physical unit in that respect. Okay. This particular illustration suggests that in 1990 the world exceeded the planet's biophysical limits. So it's not about markets generating futures here. It's about, obviously limits to growth, that concept. And this deficit shall continue to rise inexorably under the neoliberal model. But if we are smart in managing growth, the possibility exists for the planet to sustain future development. In Hackbridge, this means you can calculate, obviously, this district's footprint of 5.32 global hectares per person, has to come down significantly to 1.5, and from 11.17 tonnes of CO2 per capita to 1.2 tonnes. So again, it's a very hard message to sell because it's incredibly stark and foreboding in terms of the savings and reductions that are required. And again, this is based upon World Wildlife Fund inspired metrics developed into the One Planet Living rather than the IPCC, which is obviously the common currency for such discussions at this particular time. Okay, so again, the starkness of it.
Sorry, Professor Mike, you have 5 minutes, please, to go.
5 minutes?
Yes.
Yes, that's fine, thank you.
Thank you.
As you can see here, we're currently at 5.32 global hectares per person. We need to get down by 90% savings in that regard. They projected that they wanted to meet this target by 2020. Okay, and this is basically the equivalent of your 50% savings, which MIT forecast from redesigning urban morphologies to change the urban tissue and behaviours alongside that, as a headline which I referred to earlier on. So there does seem to be some sort of logic following through or confirming those particular statements which have been made, just as headline statements in the press. Okay. How do we do it? Okay. Well, we did this for Hackbridge, basically. They asked us to work with them and to codify this particular process under the concept of a mass retrofit methodology. And also because they wanted to meet the equity requirement of their One Planet Living, they also asked us to develop it as a social baseline for the environmental profile and then integrate this into the economics of the particular proposal as well and see whether, in a sort of triangulation, all those particular metrics stacked up, as was referred to earlier, and therefore the demand pull would be in place to meet the particular costs. Okay, so this retrofit was basically across the whole of the built fabric, i.e. the domestic and the commercial and other spaces. It wasn't just limited to housing or anything of that nature. So we looked obviously first at the physics of the building performance, heat mapping, energy performance, carbon emissions, three-dimensional model of energy for calculating the ecological footprint, environmental profiling then of built form, construction of the social baseline in terms of the demographic, because obviously some people would gain and others would lose from these changes, and how do we then balance out so that there isn't anybody stuck in fuel poverty as a consequence of these particular measures being put in place. Transversal analysis of that, and then review stages, stage one, and then the undergridding, because that's really the superstructure component of the exercise, to undergrid it, to securitize it, to give it its diversity and make it resilient in that sense. We needed to obviously work through the district energy network as biogas, CHP, solar energy, wind power being folded in to the conventional supply of energy, which obviously does make up the bulk of the consumption at this present time. So it's complementary, as has been referred to again, time and time again this morning. It doesn't try to adjust the market in any way. It tries to work and maybe bend the market in a direction which can leverage greater sustainability and, if anything, be smart in that particular objective. And obviously, ultimately, put in the smart grid, the energy company as an ESCO to manage peak loading, dynamic pricing, when obviously, there's too much wind at the wrong time of the day, or there's too much sunlight at the wrong time of the day. So that isn't wasted, it is stored and then it is distributed. So there is, again, efficiency within the system there. And then review of stages 2, and obviously plan your action based on that. But what are the economics of this then? Yes? Those are some of the GIS applications which we've drawn up, which identify the demographics of it, and therefore who's going to be better off and who's going to be worse off, and how we can put measures in place to balance those particular costs and benefits as a consequence. And they're even looking at geothermal applications at the present time, but the costs do seem to be quite prohibitive. Okay, so this is the sort of bottom line economic sustainability. Stage 1 for 4,000 residents in terms of the built environment is £120 million. Okay, will save 3 tonnes relative to its comparator, and that's 50% of the total. And then stage 2, again, total of £150 million, slightly higher, but that's because of the high cost of the biogas CHP plant, and again, saving the similar amount of carbon for that particular application. What total adding up to 78% in terms of reduced carbon emissions from what obviously is the replacement in terms of the existing technologies for the infrastructure that currently supplies this particular district. As for stage 3, in terms of smart grid, worked on a micro level because we know that our grid in the UK can't actually take energy back into it without crashing because it is so, fragile in that sense.
2 minutes to go, please.
That would probably provide about 5% extra on top of the 78. So there's potential of 80% plus carbon savings from changing the urban fabric in that sense and undergridding that urban fabric with these particular newly renewable sourced energy supplies as a main component of that retrofit. Okay, thank you very much.
Thank you very much, Professor Mike. And you still have 1 minute to go, but you finished it earlier. Thank you very much indeed. With all my respects to my respective audience, we are late, we are running out of time, and the issue is in your hands. It depends how many questions you're going to go. And please, before we open the floor for questions and answers, I would like to remind for whoever will have the chance to ask, introduce his name, please, and the company or governmental institution or governmental business where he works. And he can mention the question to whom, either to Professor Michel Foss or to Professor Mike. Please make it short as much as you can. Please, here.
Thank you. Professor Sid Ahmed bin Rawan, Carlson School of Management, University of Minnesota. I have a question actually very quick to Michel. You mentioned the US story in a very nice way, but also in a very nice pictures and graphs. And I think what was missing is simply the meaning of those changes and those transformational with respect to the relation of the US to this region, particularly the political and the geopolitical relationship as well. Thank you.
Yes, good point, and a very good one. And I would have to say that actually this is the puzzle right now. There is a desire to argue that our ability to produce from tight rock plays changes the picture for the United States. There's a very strong and very sympathetic contingent in that regard. And on the other hand, these are fragile plays. They need a lot of policy and regulatory support. They require lots of money. They require good investment frameworks, a healthy economy, and a sensible regulatory approach, meaning a regulatory approach that's consistent between the states and the federal government. And those of you who know the United States know that the states have a great deal of power. In fact, the states have more political power than the federal government does. And that's always a tough lesson for people. So if you think that Washington is speaking on behalf of the oil and gas producing states, that is actually not true. And you actually need to go and visit Oklahoma, North Dakota, Wyoming, Texas, Louisiana, and now Pennsylvania, Ohio, and a few other places to get a sense of how people in those locations feel about these businesses and all of the aspects associated with them. So, as I said, I think the dilemma for the U.S. right now is that we're in a time where people would like our interests to be different. They would like our view of the world to be different, driven by our own internal energy supply to balance situation. But that supply balance situation is tough to sustain. It's very demanding, and it puts us in a position in which a slight turn of events, and we are right back out in the global markets. And therefore, we need to keep the skills that we've had before in terms of international relations. So it really is a puzzling time, I would say. That's, I hope, a clear answer for everyone.
I think Professor Michel, it is different from the rest of the world, you know, the way that it, as you mentioned. So it's not centralized, centralized, and taking the decision to it, right?
All right.
So this is what is different from it.
Very different. Constitutionally, the states individually have a great deal of power.
Good.
And authority. And even when rules are passed at the federal level, they have to be implemented at the state level. So anything that gets done at the federal level, whether it's to manage environmental effects or to manage how infrastructure gets built, it's up to the states to set the course on those rules.
Thank you very much. Jafar Al-Ta'i, Emirates Policy Center. Can you hear me? Question for Dr. Foss. What do you think of the recent exploration efforts on the unconventional plays in Abu Dhabi? Some exploration efforts have happened in Abu Dhabi, drilling unconventional wells by ADNOC. So, are you optimistic about the prospects of good unconventional reserves here? And second question, what's your opinion of the evolution of a kind of Henry Hub pricing system in this region for gas? Thank you.
The first question is easy. I don't know. I haven't had the opportunity to look at results from your drilling. If you share the information, I'll be happy to give you a comment on that. There may be geologists inside the Bureau or petroleum engineers inside our engineering program who know something about what's actually been achieved here, or if somebody else wants to comment on that.
Yeah, I just want to say that Dr. Michel, this is her first visit to UAE, and she's not quite familiar with exactly, the geography and geological perspectives of drillings. So this is a part of, she's right.
I would say that, being familiar with geology in the region, generally speaking, what I said before holds true. You have world-class conventional oil and gas assets. I will be amazed if you don't have world-class unconventional resource assets as well. But every place is different. The origin of the shales here may be different. There are a lot of things to consider. On Henry Hub, this is something that everybody asks all the time, and it's especially lately with lower oil prices and other things. The question has been for some years, when would other countries, other regions get a price discovery mechanism like what we've had? What could the impacts be? Creating a market hub for natural gas is actually fairly easy. It's once you decide that that's what you want to do, if you have a way to pool production and a way to combine that with key things like ability to store natural gas, pipeline systems to be able to deliver natural gas, and some financial market support, you can do that. You need ways of setting rules so that participants cannot create market power at market hubs, and I would be very blunt and say that in looking at certain locations like Eastern Europe and Russia, this is the real challenge, trying to have a market hub for a natural gas price there that's not controlled by one country in particular who may have an interest in influencing what that natural gas price looks like. And that's the tough part. The tough part is building the regulatory framework to support a market hub.
Thank you very much.
Thank you. Halima Swedan from UAE University. My question is for Dr. Michel. Thank you very much for the presentation you gave. It's a shame we didn't get to see it all, but thank you for the effort that you made. You showed us quite a lot of economic models and future predictions. So I was just wondering, how did you make those models, and are there any special considerations that you have to think about when you're modeling oil and gas in particular compared to, you know, other economic models, or is it just your traditional econometrics and economic modeling? Thank you.
Great question. And what I will say, and this will be a very radical statement, we do not try to model, especially if what we're interested in is a price outlook. These are very detailed scenarios. And behind these scenarios is a huge amount of analysis to understand the fundamentals. And what I would say out there is that this is the thing that we don't do enough of. So all of you who are students or who are at universities, everybody wants to build models, and you know the problem with building models is that data is lousy and information is lousy. And so the modeling results tend to be lousy as well. And this is just a problem that we have. And so what we try to do is actually different. What we do is we build ground up data, whether it's on a resource like oil and gas or coal or whatever it is, whether it involves infrastructure, electric power generation, petrochemicals plants, whatever. We look to see what people are doing, what the capacities are, and how that capacity might get utilized given different market conditions. And we study the markets themselves intensely, all the good and the bad and the ugly. And so that's a very different approach with a very different kind of an outcome than trying to build an econometric model. We do that too, and we look at econometric models to test our own scenarios and test our own scenario results. But I think kind of the biggest mistake that we've made actually for the past 30 years in looking at this enormous arena of energy development is to trust in model building when our inputs are so deficient as we try to understand what people do and how we'll do it and how we behave. We actually don't understand human behavior very well in order to make predictions.
Thank you very much. Can you stand for the photographing now for the video documentation?
My name is Mahmoud Sharif Mahmoud, and I have a question for Dr. Michel, unfortunately, sorry, Doctor. And my question is, what is the amount of U.S. shale oil if it is to be converted to traditional oil? To be more specific, by how much the U.S. proven oil reserve will increase in comparison to GCC proven oil reserve? Should I repeat my question?
Very roughly speaking.
Yeah, it is clear.
Yeah, I think it's clear enough. And just, I'll quickly say, shale oil is dominating onshore. We have onshore and offshore locations. We do not have shale plays offshore. In fact, Queensland, Australia, they're making a very brave attempt to try to look at unconventionals offshore of Queensland for natural gas development, but it's really tough and very expensive. Onshore, shale is dominating oil production for us. We have very, very mature oil fields anyway, and so this has rapidly taken over as the dominant percentage and will remain that way.
But by how much it will improve the amount of U.S. proven oil reserve? I mean, would it go by 20%, 30%, 40%?
Oh, 50% or more. What I showed you in the data, which you will be able to look at, I assume that the slides will be available to everyone.
I came late, that's why.
Yeah. Everything that I've showed you in reserve growth is most of that is onshore shale plays, and then Gulf of Mexico deep water. The two is the other really major location for oil development. Okay?
Thank you.
Thank you very much. The gentleman there. Yes, you, please. I don't want you to feel bad about me.
Tim Gould from the International Energy Agency. I did have a question for Michel, but I shall follow the chairman's advice and try and come up with also a question on smart cities. I wanted to ask how much of what you're describing is reliant on in the end on behavioral change amongst consumers, and how much can be, in a sense, imposed on a system by smart policymakers?
Thank you. I think the implication you're saying is that the system we currently have doesn't fit the expectations of the future regarding climate change, and that mismatch is possibly too, strong or too big a gap for us to bridge. There is that issue. Behavioural change, yes, is one of the 5 components of the sort of principal component model. And can be identified as about 5% of extra savings. So we can firewall it in the sense that it isn't absolutely structurally fundamental to whatever else goes on. It will just undermine the level of savings which will be realised from the rollout of the other components up to the point where people do occupy and use and therefore consume the energy in the end. But one of the other major points as well is that much of the investment is going to come from the likes of you and I anyway, as either members of families, as parents, or as workers in companies, etc., etc. So in terms of cultural change, yes, there's an even greater challenge to take on there in terms of finding some other model which isn't totally corporate dominated and finding some, what we used to call mutual associations that can actually bring forward and leverage as intermediaries the type of capital that is required to deliver on these particular climate change expectations. In the UK, well, in Europe, you've got the Climate Change Fund, the Green Investment Bank, etc., etc. The European Commission, desperately disappointed with the little uptake there is in many of these funds which they put together in the past. So they don't seem to be convincing businesses to drive forward in this particular way. That is a major challenge to make this step forward.
Thank you very much. Dr. Mike, please, the mic. Okay, yes, please, after.
Just again, to keep the conversation about the smart city, Sid Ahmed bin Rawan, University of Minnesota. I think in addition to the technology, you also have to have some cultural shifts in the mindset of people. I've been here for about 2 months and I have heard a lot of things about smart city in UAE, Dubai particularly, but actually when you're driving or when you're biking, there isn't even actually smart sidewalk for bikers, for instance, and that's something that has to come from policymakers first to induce that cultural shift and that cultural change. So it's important that we coach these technological changes with some cultural behaviors so they are able to make people change and to become smarter in the way they live. Thanks.
Yes, no, I couldn't agree more, actually. I mean, that's why I put so much emphasis on demonstrations, the pilot cases which do prove the exception to the rule and allow us to use those as rich, experiments to try and make more generic within the system.
من دولة الكويت سعادة الأستاذ عباس علي النقي تفضل.
Thank you very much, Mr. Chairman. My name is Abbas Al-Naghi, Kuwait. Professor Deakin, you have mentioned the IPCC reports, and you were referring to some of their intervention within these. And you know that the IPCC reports are not reliable in many, many cases, because even within the UNFCCC, that they do not believe or they do not stick to the UNFCCC reports. So how can we rely on such reports that we as negotiators within the climate change negotiations, during the meetings and during the conferences, the COPs, we always say our views regarding these reports, IPCC reports, because they are directed by what you want to put in the report and the model itself, and what you put in the model and you get in and you take out from the other side. So the IPCC reports are not every time are reliable. Thank you.
Yes, again, I have great sympathy with that. We worked with the city of Stockholm on the seaport proposal, again under the auspices of the European Commission. And they were adopting this other model, this IPCC model, which was endorsed by the C40 group, etc., and that particular protocol. We worked with Technical College, King's Technical College in Stockholm, to go through the protocol and to develop the metrics. Once, obviously these are scenario-based because they're based upon future visions and strategies to be rolled out over the next 20, 25 years. So there is always that degree of uncertainty in terms of the future. But there were a number of scenarios developed. And one of the real hardcore scenarios was to get carbon emissions down to 1.5 per capita. And they did trial that particular lifestyle as a demonstration, as a sort of living laboratory. And people found it a little bit tight, a little bit too austere. So they did lift it back based upon the feedback and on the stakeholder analysis and all the rest of it, to around about 2.5 to 3. Okay. Now, Siemens Green Global City Index and its particular innovation metrics is classifying all the leading experiments of this type as world-class if they reach 3 tons per capita in that respect. That seems to be the new global target for developing a fabric in the urban fabric which people are comfortable with, particularly in European or North American, Canadian environments anyway, to drive down to that level. So that would probably be about 1.75 to nearly 2 planets that we need to sustain that. And at the moment, the UK needs 3.2 something. America needs 5. So it's a good, it's a good way of leveraging change and obviously bearing down on the levels of consumption, and also embedding those habit persistent practices, which will then cultivate, those types of values, and also hopefully the outcomes which they represent. So yes, the data, it would be great if it was a lot stronger, but it would be great if the IPCC panel data was stronger and more universally accepted, et cetera, But those constituencies aren't going to go away, are they? They're going to remain as major pressure groups, lobbying for change, and there's a lot of political capital across the whole of the globe in actually signing up to the climate change agenda. It does leverage a lot of support from voters because it's benign, in that sense, as a particular strategy. So again, I can't see that going away. It's really more of a rallying call for the likes of ourselves to make the data more robust, and more reliable, and add extra weight to the argument and force it through with a degree of rigor, that we would like to see evident in these instances. But all the headline figures are pointing in the same direction. There is convergence there. I mean, I started research in sustainable development around about 95. And as I say, you could count on, 2 hands how many people were researching that subject. And now it's exploded, beyond all recognition as a particular subject and as a scientific issue and disciplines, et cetera. So, it does seem to have struck a chord with our sensibilities. And no doubt, SMART theme will further augment that and hopefully consolidate on it as well. Thank you.
Thank you very much, Mark. I think we have the last question, if you allow us. And Professor Abdullah, yes, please.
Thank you very much. Abdullah Muhammad Al-Hassan, University of Jazeera, Sudan. I would like first really to thank Dr. Ali for giving this opportunity to be here in this lovely country and to participate in this very important conference to tackle this very hot issue, energy. I have only one question, General, for our 2 distinguished speakers. Coming back to the theory of supply and demand in energy, what shall we do to narrow this gap between supply and demand and to give our consumers energy prices in affordable prices so as to implement the concept of sustainable development in protecting our fragile environment? Thank you.
To whom is this addressed? Both of them, okay.
I don't remember which of our chairpersons today brought up the point about administered pricing and subsidies. I believe it might have been in the previous panel. It's hard to look at the world and not see how much intervention there is in markets by governments and how serious of an effect that is in terms of supply and demand. We have huge parts of the world where energy demand is much higher than it would be if customers were actually paying market denominated prices. And that's a political question, what to do and how to deal with that. On the other hand, you want people to have affordable energy. I would argue that if you gave people an open price, which might be high, that would probably spur investment in things that could give people affordable energy. But having said that, let me make another really radical statement in this time of low oil price and this sense of surplus in the United States and all of that. I have been around the block in this business a lot, and there isn't much out there that I would argue passes the smell test. And this is everyone in my staff, we joke about this. If I don't like something or if something doesn't feel right to me in these businesses, that's the first thing I ask all of my researchers. Does it pass the smell test? And the problem is that a lot of the stuff that we try to do doesn't pass that test. We're spending a lot of money developing renewables in the United States, so I'll pick on us and to make the point. We're building wind power all over Texas, all over the western United States. We back it with natural gas. We run natural gas turbines on a continuous basis. We call it spinning reserves. In order to have the electric power available to the grid when the wind varies, because wind varies all the time, all day, every day. That is a silly way to use natural gas, but that's what we're doing. But the customers are not paying that price. They're sheltered by federal production tax credits and by averaging in the rates of electricity that customers use. These are the kind of things that I think are tough to understand and tough to bring into the picture. They cloud analysis. They make us think that we're accomplishing things when in fact we're actually not. And we may actually be creating unintended consequences that we can't possibly deal with later on. And so I just would raise that as a question. Mark's shaking his head. I think he agrees a little bit. Yeah, we all want win-wins, but there aren't very many out there like that.
Yes, Mark, please.
Yes,
Mark.
it's a very challenging question, I have to confess. But obviously, my concern, I think, the general concern is energy security, isn't it? And continuous supply, and no breaks, no crises, etc., to cause disruptions in the overall system and whatever mayhem that could cause. Diversifying your supply or sources seems a very sensible thing to do. So folding in renewables in itself from an energy question, even with conventional energy production, seems quite sensible because you're increasing the mass of volume of energy which is available. But in terms of obviously the green agenda and the fact that it's clean, then again it does seem to be this notion of a win-win in that regard. Okay, so I wouldn't argue renewable energies down. I would try and get greater efficiencies from them. And I think that it's the synergies with the legacy system relative to the new, which is as much a problem as anything else. Wanting steady state rather than step change, or rather than, I wouldn't even call it radical change, I would call it step change. But all those technological issues and all those climate issues aside, even in the most sophisticated and advanced consumer economies throughout Europe and North America, fuel poverty is crippling, absolutely crippling. And that's one of the main challenges across the world, is the overall price and cost of energy for the general member of the public, either the man on the street or whatever. Even the intensive case study that we did of Hackbridge, the diversity of impact was so marked. You had a paradoxical situation whereby people that were making no contribution to global warming whatsoever were actually worse off as a consequence of renewable energies being brought into the system. That's the level of contradictions which are systematically ingrained, structurally, consistent within our system. And these are some of the root causes for these subsequent paradoxes which emerge and come out as manifest themselves as, well, no, we don't want green anymore, that's stupid, blah, blah, blah. So don't expect logic within the actual morphology of the system that you're working with. The abstractions of the market will, give some sense of purity there, but the diversity is incredibly deep. And I think, fuel poverty is going to be one of the major challenges of the future, and finding ways to actually overcome that and make fuel affordable in that regard. Okay.
Thanks, Mark. I don't want anyone to go from this hole and he's angry or upset. There's a lady who was raising her, her hand. Please, you can ask your question, and that will be the last question, please. There's a lady there. Yeah. We want to be biased and democratic.
Thank you. Actually, I had a rather simple technical question for
your name, please.
Dr.
Your name, please.
Sorry. Alexandra Houston from the Swiss Embassy. And yes, I had a rather simple technical question for Dr. Voss. I actually wanted to ask, because the US was until recently the largest oil importer, well, now obviously they're trying more and more to move towards being sort of independent with respect to their energy production. But from what I understand, you mostly have gas than oil. But so my question is actually, how interchangeable on a sort of everyday level is gas and oil? So how much, if you were most using oil before, how easy is it to switch these to gas use? Thank you.
Not. Gas is gas. Oil is a liquid. Liquid fuels are wonderful. You can move them, you can use them. It's a cinch. Natural gas is very demanding to use. You have to contain it in infrastructure. If you're not going to use it as a gas, then you have to transform it into a phase that works. So what we're trying to do is chill natural gas to liquid form and use liquid natural gas as a replacement for diesel in transportation. That's one idea. The other one is the one that I mentioned, where you convert natural gas in a chemical process to a form that looks like a middle distillate, like a light fuel oil that can go into a refinery and be processed. These things are very complicated. Or you burn a lot of it in electric power so that you can provide electricity for electric vehicles. And since the main thing that we do with oil in our country is transportation, so the fundamental line in the sand, to, I guess, draw on a common analogy out here perhaps, is whether or not you can move natural gas into the transportation sector successfully, and that's the bet. To do that, we need a high oil price. None of this stuff works where we are today, and it won't work unless you see a significant appreciation in oil price again, or a great deal of policy intervention, which I would argue is not the right thing to do anyway. So there you are. I hope that helps a little bit.
Yeah, just want to add a comment to Dr. Michel here in UAE, and particularly in Abu Dhabi. We start using the, what do you call it, the CNG.
Yeah.
They call it the NGV. All of you know in the ADNOC petrol stations,
yeah.
the NGV. natural gas for vehicles. The number is increasing, especially within the government, police sector, private sector. We are moving towards using the NGV as well as the EV, but it's going, the electrical vehicles. And inshallah, coming up the hybrid cars, where you use just little amount of hydrocarbon just to start the mechanism, and it goes all by electric. So this is the hybrid. And our last World Environmental Day in our Sheikh Khalifa Energy Complex, we celebrate the World Environmental Day, and the exhibition was about the future transportation or future vehicles. So we demonstrate from Mazda. Mazda, they are using, as you know, the EV. They're using the solar, transportation. They are booms here, and as well as now the NGV. So it is towards to minimizing the emission of CO2 and greenhouse gases, and to contribute in a green perspective, UAE as trying to challenge to be the fifth, especially Abu Dhabi, the fifth government in the world in the green perspectives. With this, I would like...
Can I just, one quick intervention? And I think that's a very optimistic story that's easier to achieve in countries other than ours, because we have an enormous petroleum transportation fuel system in the United States, and it's very, very difficult to push natural gas into that framework. So I just add that.
I don't want to take much of your time. I was so pleased for such an interactions and feedback from the audience. On behalf of you all, I would like to thank Professor Michel Foss and Professor Mike Deakin, as well as we like to thank especially the Center of Strategic Research Strategy, and all who have this event a successful one. With all your appreciation, we end this session for the second panel of the first day of the 20th Annual Energy Conference. Thank you very much, and lunch is served.